Okay, this is going to be our lesson on area of parallelograms. We are going to do 2 warm-up problems because you will have one in your homework that's similar to number 1. So it will be a parallelogram problem, but you'll do the exact same thing, and you'll see why once we do the formula for a parallelogram. So it says, what is the base of a rectangle that has an area of 120 feet and a height of 8 feet? So if this is the area and this is the height, and our formula is area equals base times height for a rectangle, we're going to put 120 in for A for area. So 120 equals the height we're going to put in for 8 feet. So 8 in for H, so B times 8. So we're solving for B, we're solving for the base. B and 8 are being multiplied, so I want to divide both sides by 8. So I'm going to do 120 divided by 8, and my base is going to be 15 feet. Not 15 feet squared, because it's just the length of the base, it's not the area. So then we talked about how with a square we could use this formula, area equals base times height, and that usually works just fine. But if we had a problem like this, what is the length of the side of a square with the area of 529 centimeters squared? So again, our area is this, so we want to plug that 529 in for area, so 529 equals side squared. So that's only going to work in this formula. If I put in 529 equals base times height, I can't solve that. If I use this formula, which also usually works for a square, I can't solve that because I have 2 variables in my equation. I only want 1 variable, that s, so this isn't going to work for me. But if I have 529 equals side squared, I can square root both sides. And so if I take 529 and take the square root, I know the side of the square is 23 centimeters. Here's my answer for 1, and there's my answer for 2. So again, in like number 1, you're going to have a problem like that in your homework, where you're going to be given the area and either the base or the height of a parallelogram, and you're going to find the other just by dividing. And so we see that, we'll see that with triangles, we can see that with any shape. But today we see that with parallelograms, and the reason this number 1 in the warm-up is nice is because the area of a parallelogram is base times height. So area equals base times height, just like the formula for a rectangle. Because if we think of a parallelogram and we think of a rectangle, they're very similar. We know they're both parallelograms. And the parallelogram is really just a rectangle that's been kind of pushed on its side. It's more in that like oblique position than in that perpendicular position. So when we use the base and the height, what's important to know for our next 2 lessons is that the height is always perpendicular to the segment, is always the perpendicular segment to the base. So we need to look for a right angle when we find a base and a height. So we're going to see extra information in some of these problems. So if we look at number 1, we have 3 different numbers, but we only need 2. We want to plug in a base times a height. So there's 1 number I'm not going to use. I want whatever 2 numbers are connected to this perpendicular. So if I draw that perpendicular, this bottom touches that perpendicular, that right angle, and this vertical touches that perpendicular. This is extra information. That's the side of the parallelogram, and I don't want that. I want, see, remember the perpendicular sign is this, and this, when I trace over it, makes the perpendicular sign. That's what I'm looking for a base and a height. So I'm going to say area equals 5 times 4, and that area is going to be 20. 5 times 4 is 20 inches squared. So again, in number 2, we have too many numbers. I'm looking for the perpendicular. I'm looking for this right angle, and it will be there for you. The right angle will be given to you. This is not part of that perpendicular. This is. I extend that base and draw in that height, I get that perpendicular. So area equals that base times height. Base is 2. This is just the base right here. We don't care about this over here. That just extends out to make that perpendicular. And the height is 3.5. It's okay to get decimal answers. This actually won't be. 2 times 3.5 actually gives us 7. But if it were a decimal answer, that would be fine. So area equals 7 centimeters squared. We don't have to have a picture for a lot of our problems, because when we only need 2 things to plug in, if those 2 things are given to us, it makes the problem really easy. So find the area of a parallelogram with a base of 12 meters and a height of 9 meters. So area equals base times height. I want to find the area. I'm told the base is 12 and I'm told the height is 9. So area equals 12 times 9, 108 meters squared. And remember, I'm using meters squared, centimeters squared, inches squared because I'm doing area. And really what's happening is it's meters times meters, and anything times itself is squared. And then something that you'll see sometimes also as extra information is an angle measure. We don't care about angle measures. We only care about bases and heights for parallelograms. So far our base has been on the bottom because that's where it's been sitting. But remember, in a parallelogram, I'm going to move back up to one of these, the bottom is congruent to the top. So if that's 5 inches, this is 5 inches. If this is 2 centimeters, this is 2 centimeters. So down here, this is the base. It's not on the perpendicular, so if I draw in my perpendicular, I can move that 20 inches down here because those 2 segments are congruent. So I have a base and a height now connected to that perpendicular. So area equals base, 20, times height, 6. 20 times 6 is 120. Area equals 120 inches squared. So you're only going to do 4 problems. 3 of them are pictures. One of them is in words, but that one in words is more like this number 1, where you're finding a base or a height given the area.